Assumption 6.2.1, that is taken from Hogg, McCain and Craig's book. We continue from the regularity conditions number 3 and 4, that are the probability density function is twice differentiable as a function of theta. The second one, that is the integral f of x theta dx can be differentiated twice under the integral sign as a function of theta. One thing is very obvious from the first 4 regularity conditions, that theta does not appear at the endpoints of the probability density function, that is f of x greater than 0. जो probability density function का इंटरवल है उसके एंड पॉइंट्स में थीटा हमारे पास अपीयर नहीं होगा, और हमारे पास जो इंटीग्रेशन है और डिफरेंशिएशन है दैट कैन बी इंटरचेंजेबल, हम इसको इंटरचेंज कर सकते हैं विद रिस्पेक्ट टू थीटा. The basic objective of this assumption is that we find an identity which we can use in further discussion. So we start with the following identity, that is a simple probability density function, that is integral from minus infinity to plus infinity f of x dx, that is equal to 1. So we start by differentiating it with respect to theta. When we differentiate it with respect to theta, we can write it as this one. On our right side, 1 is a constant. When we take the differentiation, it is equal to 0. Then we multiply and divide by an identity that is f of x theta on of this function. And after solving this one, we will obtain this result, that is curly log f of x theta divided by curly theta f of x theta dx. जब हम इसको open करेंगे तो we obtain the previous result. From here, we can write it as in term of expectation, because this is a random variable and the rest of the things represent the probability density function, and we can represent it as in term of expectation, that is the expected value of this random variable, and this is equal to 0. And this is the useful result. We will use this result in later on, and we can see that this random variable, the expected value of this random variable is equal to 0.